So hey guys, welcome back to bit manipulation series. In the last video we saw how to find whether a number is even and odd using bitwise operator, or specifically using bitwise AND operator. In today's video we are going to discuss one more question. The question is how to find if a given number is power of 2. So let's first understand the problem, and then we will discuss both approach, brute force as well as the bit manipulation approach. So it will help us understand why bit manipulation is more efficient and when to use it. So let's first understand the problem. So what do we mean by power of 2? So power of 2 basically mean that any number that can be represented as power of something. Let's understand this with example. Let's say we have a number 1. Okay, so 1 can be represented as 2 to the power of 0. Let's say we have number 2. 2 can be represented as 2 to the power 1. We have a number 4. 4 can be represented as 2 to the power 2. We have 8. 8 can be represented as 2 to the power 3. So these are the number that can be represented as 2 to the power something. So in general 2 to the power of x, where x is a positive number. Okay, so we have to find out that which all number is 2 to the power of 2. It means that we can represent that particular number as 2 to the power of something. So if a particular number is 2 to the power of something, then we can return true, else we will return false. So what it means, like the other numbers, let's say 3 cannot be represented as 2 to the power something. 6 cannot be represented. 10 cannot be represented. So how we will find out? Okay, so let's first discuss the brute force approach. Approach 1. So in this approach, if we understand the problem can be represented as 2 to the power of something. It means that this particular number is divisible by 2. Okay, the logic is very simple in brute force. If a particular number is a power of 2, then if you will keep dividing that particular number by 2, at the end you will get a result 1. And if the particular number cannot be represented as 2 to the power of something, then it will not return you 1 at the end, or it will not be divisible by 2. Let's understand this with one example. Let's say 8. So as we have seen that 8 can be represented as 2 to the power of 3. So how to find out with this approach? So the first step is to keep dividing the particular number. If we divide 8 by 2, we will get the answer 4. Now again, if we divide 4 by 2, we will get the answer 2. If we again divide 2 by 2, we'll get the answer 1. So at the end, when you are getting the answer 1, it means that that particular number can be represented as 2 to the power of something. Here it is 2 to the power 3. Okay, so this is the approach that you can follow as a brute force approach, where you have to keep dividing the number until you reach 1 as a result. Now what will happen if you will try to divide a number which cannot be represented as 2 to the power of something? Let's take that example as well. Let's say we have a number 12. So if we will divide the number 12 by 2, we will get a result of 6. And if we divide 6 by 2, we will get a result of 3. And again, if we try to divide 3 by 2, we will not be able to divide it exactly, and here we will get a remainder of 1. So that particular number 12 cannot be represented as 2 to the power of something. So I hope you understand the approach. The approach is very simple. If we keep dividing by 2, and if it is divisible and without giving any remainder, then that particular number is a number of power of 2. And if a number giving us a remainder while dividing it by 2, then that particular number cannot be represented as a power of 2 number. Okay, so the approach is very simple. Let's understand it with code. Let's say we have to return true if a number is power of 2, and we have to return false if a number is not power of 2. So we will take a function. What kind of function we can take? We can take a boolean function. So here I'm just showing the C++ code, but you can refer the note in the description, in which I have explained both in Java as well as Python language. So we will create a boolean function in which we are getting an input n. Now the first step that we will check is the number that we are getting as an input for this particular function, that particular number is a positive number or not. So first condition is if the number n is greater than or equals to 0. If the particular number sorry, if a number n is less than or equals to 0. If the particular number is less than or equals to 0, in that scenario we don't even need to check, we can simply return false here. Now in the next step, let's say that particular number is a positive number, then we will write a loop, because here we have to keep on dividing the number until we get a result 1, or if the remainder is returning something. So here I'm going to use a while loop. So what will be this condition? Okay, then we will write the code. So this particular condition, if we see here, it is returning a remainder of 1. It means that at any step, if that particular value is not returning 0, then we can return, right? Or we can terminate the loop. So here we can define a condition that if a particular number is getting divided by 2, then its remainder should be equals to 0, or at any point if the remainder is not 0, then we will end this loop and we will go out of this loop. So until and unless this condition is true, we will keep on dividing the number. Okay, now inside we want to store that particular result, and we will keep on dividing the number. So here we will use the same value to store the number, and we will divide the number by 2. That's it. This is the simple logic that we have to write, and it will keep on dividing the number, and it will store this after division it will store it in the same variable. So after that, when the loop will terminate, we have to check whether that particular value n is storing 1 or not. So in the time of return, we can check if n is equals to 1, then it will return a true, else it will return a false, right? So I hope you understand the basic approach where we are dividing the number as many times until we reach 1. The same code I have written. What will be the time and space complexity of this problem? So the time complexity of this problem can be calculated. If you see, if we have a number 8, in the first step we are dividing it by 2, it means we are getting 4. In the next step, the 4 is again dividing by 2, we are getting 2. The 2 is again dividing by 2, we are getting 1. It means in each step we are reducing the problem by half. So in that scenario, the time complexity for the particular problem is O of log of n, and the space complexity is constant because we are not using an extra space. So this is the brute force approach. Now let's discuss the bit manipulation approach, or the bitwise approach. Approach 2, bitwise approach. Now let's observe those number which is a power of 2. If we take example 1, now in bitwise we perform operation on binary, so convert it to binary. 1 can be represented as 0 0 0 1. The next number we have is 2. 2 can be represented as 0 0 1 0. Next we have 4. 4 can be represented as 0 1 0 0. Next we have 8. 8 can be represented as 1 0 0 0. So we have taken 4 examples. Now what you can observe from the binary representation of all these numbers, if you are able to find out, then in each binary number we have only one bit as a set bit. In each number we have only one bit as a set bit. So let's take one more example. Okay, let's say 16. 16 can be represented in the form of 2 to the power. So here the 16 can be represented as this. Okay, so this is the binary representation of 6, and here if you observe, here also only one bit is a set bit. So this is one observation we can find out from all the number which can be represented as 2 to the power of something, that it contain only one set bit. Okay, now we have to use this information to solve this problem. Now how to use it? Now if you observe, if let's take one example. Okay, 8, and 8 is 1 0 0 0. Now if somehow we find a number, where the number is opposite of this number, let's say here the first bit is a set bit and the remaining is unset bit, and somehow we are able to find a number where the first bit is a not set bit and the remaining bit is a set bit. Now why I'm trying to find this particular number? I'm trying to find this particular number because if we see a pattern here, that if we do an AND operation of this two number, we will get 0. Okay, so I'm just trying to find this pattern here. Now let's say how to find this particular number here. So we have observed here that if we if we subtract 8 by 1, we get 7, and the binary representation of 7 is 0 1 1 1. So if we subtract 1 from the given number, then we are getting the desired value. And if we do AND operation between these two numbers, 8 and 8 minus 1, we will get a result 0, which you can see here, right? Is it working for all the numbers? Let's check. Let's take one more example here, the number 4. If we see binary representation of 4 is this, and if we subtract minus 1 here, we get 3. The binary representation of 3 is 0 0 1 1. And if we perform AND operation between these two numbers, which is 0 1 0 0 0 0 1 1, we will get 0 0 0 0. Here the answer is 0. So by this observation, we can come to a generalized way that if a given number n is a power of 2, and if we are performing AND operation between the given number and a number less than that, then as a result we are getting 0. So this we can use to solve this problem. Okay, now let's understand with one different example where the number is not power of 2. Let's say we take an n value as 6. So the binary representation of 6 is 0 1 1 0, and if we subtract minus 1, we get 5, and the 5 is represented as 0 1 0 1. And if we perform AND operation between these two, we are not getting 0, which is not equals to 0. So this is not working for the number which is not a power of 2 number. It is only working, this particular logic is only working when the particular number is power of 2 number. So from this particular trick, we can find the solution for this problem very easily. Let's understand this with code. So it's very easy. I'm going to show the C++ code here. Boolean function, it is getting a value n. Now let's say first we have to check if the given number is positive or not. So we will check if n is greater than 0, then only we will return this formula where n is having operation with n minus 1, and if it is equals to 0, we are getting a value true, else false. That's it. Else return false. And what will be the time complexity for this particular problem? The time complexity is O of 1, and the space complexity is also O of 1. See, so by using bitwise operators, we can easily solve a problem whose time complexity was log n with a solution with time complexity of O of 1. So I hope you understand the problem and the approach that we have followed here. So I hope you understand both the approach. Where the first approach we have used brute force, by using loop we have solved the problem by keep on dividing the number by 2, where in the next approach we have observed the binary representation of the number and we find a pattern between the number after performing the AND operation between the number which can be represented as a power of 2 and the number less than that particular number. We are getting a result is 0 when we are performing AND operation between these two numbers. So from this observation we generalize a formula that if we perform AND operation between the given number and a number less than that, then we will always get a 0 if that particular number can be represented as power of 2. Else we will not get 0, we will get some other result. The code is quite simple. If the number is positive, we will return true if this particular equation is equals to 0, else we will return a false. What will be the time complexity? The time complexity is O of 1 and the space complexity is O of 1. So thank you for watching. from the next video we will discuss one more new question. Bye bye.